Good evening and welcome back. Tonight we're diving into one of the most controversial and fascinating theories about human history, a story that challenges everything we think we know about our ancient past. As always, let me know where in the world you're listening from. Get cozy, settle in, and let's begin. Imagine for a moment that everything you learned in school about ancient history was incomplete. Not wrong necessarily, but missing entire chapters, whole civilizations erased from the record by time and catastrophe. Imagine that 12,000 years ago, when mainstream archaeology tells us humans were nothing more than simple hunter-gatherers scratching out survival, there existed a civilization with knowledge and technologies that would astound us even today. This is the theory that one man has spent over 3 decades of his life investigating, documenting, and defending against a tidal wave of academic criticism. His name is Graham Hancock, and whether you consider him a visionary researcher piercing through the fog of historical amnesia or a pseudoscientist spreading dangerous misinformation depends largely on which experts you listen to. But one thing is undeniable. His work has captured the imagination of millions and sparked debates that reach far beyond the dusty halls of archaeology departments. His Netflix documentary series, Ancient Apocalypse, became one of the platform's most watched shows, introducing his theories to a global audience and igniting fierce controversy in equal measure. Born in Edinburgh, Scotland in 1950, Hancock didn't start his career chasing lost civilizations. He was a respected journalist and author who spent years examining international development and corruption in the aid system. His 1989 book, Lords of Poverty, was a well-received critique that established his credentials as a serious investigative writer. But something changed in the early 1990s. Hancock began looking backward deep into human prehistory, and what he found, or thought he found, would consume the rest of his professional life. His pivot came with The Sign and the Seal in 1992, followed by Fingerprints of the Gods in 1995, a book that would become an international bestseller and establish him as one of the most prominent voices in alternative archaeology. In these works, Hancock proposed something radical, that human civilization is far older than we've been taught, that advanced societies thrived during the last ice age, and that their knowledge was preserved and transmitted to later cultures after a global cataclysm nearly wiped them out. To understand why this idea is so controversial, you need to understand the standard historical timeline. According to mainstream archaeology, human civilization as we know it began around 6,000 years ago in Mesopotamia. Before that, humans lived in small bands as hunter-gatherers, with no writing, no complex architecture, no advanced astronomy, no sophisticated engineering. The progression was supposed to be clear and linear, from nomadic bands to agricultural settlements, from mud huts to stone temples, from oral tradition to written language. Each step building logically on the last over thousands of years. But Hancock looked at the evidence and saw something different. He saw advanced astronomical knowledge encoded in ancient monuments. He saw precision engineering in structures that supposedly predated the invention of metal tools. He saw connections between far-flung civilizations that had no business sharing similar myths, symbols, and architectural styles if they had never been in contact. And most importantly, he saw a pattern, a moment roughly 12,000 years ago when something catastrophic happened to Earth, something that wiped the slate clean and forced humanity to start over. This catastrophe, Hancock argues, was the Younger Dryas impact event, a time when fragments of a massive comet slammed into Earth's atmosphere, triggering wildfires, floods, and a sudden return to near glacial conditions that lasted over 1,000 years. The evidence for this impact, he claims, is written in layers of sediment across the globe, in extinction events that saw the disappearance of massive animals that had thrived for millions of years, and in flood myths that appear in virtually every ancient culture on Earth. Before this catastrophe, Hancock proposes, there existed a sophisticated civilization, one he doesn't claim to have fully understood or located, but whose influence he believes can be seen in the earliest known cultures. The survivors of this lost civilization, he theorizes, became the teachers, the bringers of knowledge, the mysterious figures who appear in myths around the world as gods or culture heroes who taught agriculture, astronomy, architecture, and writing to primitive peoples emerging from the Ice Age. To Hancock, sites like Göbekli Tepe in Turkey, a massive megalithic complex with construction beginning around 9600 BCE, built by people who mainstream archaeology describes as hunter-gatherers, suggest to him that something is missing from our timeline. The precision stonework found in ancient Egypt and Peru, created with tolerances that some researchers find remarkable for the available tools, suggests to him capabilities that deserve deeper investigation. The global distribution of pyramid structures, many oriented to astronomical alignments, could indicate, in his view, a shared knowledge base that spans continents. But here's where things get complicated. Hancock is quick to point out that he's not claiming to have proved anything. He presents his work as a hypothesis, a proposal that deserves serious investigation rather than immediate dismissal. Yet his critics, and they are numerous and vocal, accuse him of cherry-picking evidence, ignoring contradictory data, and promoting theories that undermine the achievements of ancient peoples by attributing their accomplishments to some mysterious lost civilization rather than human ingenuity. The debate has become heated, sometimes personal, and increasingly visible. Archaeologists have published scathing critiques of his work. Scientific American ran articles debunking his theories. The Society for American Archaeology issued statements condemning ancient apocalypse for spreading pseudo-archaeological claims. Meanwhile, Hancock has accused mainstream archaeology of dogmatism, of refusing to consider evidence that doesn't fit their established narrative, of protecting careers and reputations rather than pursuing truth. So, who's right? Is Hancock a lone voice speaking truth to power, challenging an entrenched establishment that refuses to acknowledge anomalies in the archaeological record? Or is he, as his critics claim, a skilled storyteller who weaves compelling narratives from cherry-picked facts while ignoring the mountain of evidence that contradicts his theories? The answer, as with most things, is probably more nuanced than either extreme position would suggest. What cannot be denied is that Hancock has tapped into something deep in the human psyche, a fascination with lost knowledge, with the idea that our ancestors were more sophisticated than we've been taught, that civilizations can rise and fall and be forgotten, and that perhaps there are warnings encoded in ancient monuments that we've failed to understand. In an age where trust in institutions is declining, where people increasingly question official narratives, Hancock's message resonates powerfully. His most recent work has focused on the Americas, exploring sites from the Amazon to the Mississippi Valley, arguing that these regions hold keys to understanding the lost civilization. He points to evidence of sophisticated earthworks, advanced agricultural techniques, and archaeological sites that challenge the accepted timeline of human occupation in the New World. Each discovery, he argues, pushes back the date of human sophistication. Each anomaly suggests capabilities that shouldn't have existed. But before we dive deeper into the specific evidence and theories, before we examine the sites and artifacts that Hancock believes prove his case, we need to understand the central pillar of his entire hypothesis: the Younger Dryas catastrophe, the event that supposedly ended the Ice Age civilization and created the need for its survivors to spread their knowledge to the scattered bands of humans who had weathered the storm. Because without this catastrophe, without this reset button on human civilization, the rest of the theory doesn't hold together. Around 12,900 years ago, something dramatic happened to Earth's climate. After a long period of warming as the last ice age retreated, temperatures suddenly plummeted. In some regions, particularly in the northern hemisphere, temperatures dropped by as much as 10 degrees Celsius in less than a year. This wasn't supposed to happen. The planet was warming, ice sheets were melting, and then, without warning, it was as if someone had turned back the clock, plunging the world into conditions resembling the depths of the Ice Age. This period is called the Younger Dryas, named after a flowering plant called Dryas octopetala that thrived in the Arctic tundra and whose pollen suddenly reappears in sediment layers from this time. The cold snap lasted approximately 1,200 years, a geological eye blink but an eternity for the people and animals living through it. When it ended, just as abruptly as it began, temperatures rocketed upward and the warming trend resumed, eventually leading to the climate we enjoy today. For decades, the accepted explanation for the Younger Dryas was that melting ice sheets in North America released massive amounts of fresh water into the North Atlantic, disrupting ocean currents, particularly the Atlantic meridional overturning circulation, which carries warm, tropical water northward. This disruption, the theory went, caused the northern hemisphere to freeze. It was neat. It made sense given what we know about ocean circulation and climate, and it was supported by evidence of massive glacial lake agassiz draining into the ocean around the right time. Then, in 2007, a team of scientists led by Richard Firestone published a paper proposing something different. They suggested that the Younger Dryas wasn't caused by melting ice alone, but by an extraterrestrial impact, a comet or asteroid that struck Earth or exploded in the atmosphere, causing widespread destruction, massive wildfires, and triggering the climate shift. This became known as the Younger Dryas impact hypothesis, and it would become central to Graham Hancock's theories about lost civilizations. The evidence presented by Firestone and his colleagues included unusual materials found in a distinct layer of sediment dating to the beginning of the Younger Dryas. These materials included microscopic diamonds called nanodiamonds, which form under extreme pressure and temperature, magnetic microspherules that look like tiny balls of cooled metal, melt glass formed when materials are subjected to intense heat, and elevated levels of rare elements like iridium and platinum that are more common in extraterrestrial objects than in Earth's crust. This layer, they argued, could be found across multiple continents, suggesting whatever caused it was global in scale. They proposed that a comet, which some estimates suggest may have been around 100 kilometers wide, had broken apart before reaching Earth, with thousands of fragments exploding in the atmosphere or striking the surface. These airbursts, similar to but far more powerful than the Tunguska event in Siberia in 1908, would have generated temperatures hot enough to melt rock, create those microscopic diamonds, and ignite continental-scale wildfires. The wildfires, according to the hypothesis, would have pumped so much soot and ash into the atmosphere that it blocked sunlight, causing temperatures to plummet. The impacts would have also struck the ice sheets covering North America, rapidly melting massive amounts of ice and flooding the oceans with fresh water, disrupting ocean currents and reinforcing the cooling. It was a catastrophe on a scale difficult to imagine, and its effects on life on Earth would have been devastating. Around the same time the Younger Dryas began, North America saw the extinction of dozens of large animal species, the megafauna that had dominated the continent for millions of years. Mammoths, mastodons, giant ground sloths, saber-toothed cats, American lions, dire wolves, and many others all vanished. Traditional explanations focused on climate change and human hunting pressure, but the timing suggested something more sudden, more catastrophic might have been involved. Similarly, the Clovis culture, characterized by distinctive stone projectile points found across North America, seemed to disappear or dramatically change around this time. Archaeological sites showed signs of abandonment. Human populations appeared to decline sharply, and when new cultures emerged, they looked different from what had come before. Something had clearly disrupted human societies across the continent. For Graham Hancock, this impact hypothesis was a revelation. It provided the catastrophe his theory needed, the event that could have wiped out an advanced Ice Age civilization while leaving scattered survivors who could pass on fragments of knowledge to the hunter-gatherers who endured. Flood myths from cultures around the world suddenly made sense as racial memories of the massive flooding caused by rapidly melting ice. The universal stories of a golden age destroyed by the anger of the gods became echoes of a real historical event. But there was a problem, or rather, many problems. The Younger Dryas impact hypothesis was almost immediately controversial. Within months of its publication, other scientists began publishing rebuttals. They couldn't replicate the findings. They couldn't find the impact markers in their own samples. They questioned the dating, the interpretation of the evidence, and the very premise of the theory. One major issue was the lack of a crater. An impact large enough to cause global devastation should have left a massive crater, or multiple craters, yet none had been found. The proponents of the impact hypothesis argued that the comet had airburst before hitting the ground, or that any craters formed were hidden under the ice sheets that still covered much of North America at the time, and were later obliterated as the ice melted and flowed. Another issue was the distribution of the proposed impact markers. While some researchers reported finding them in sediment layers, others sampling from the same time period found nothing unusual. Critics accused the impact proponents of inconsistent sampling methods, of looking specifically for materials that would support their hypothesis while ignoring context and comparative data. The wildfire evidence was particularly contentious. The impact hypothesis suggested continent-scale burning, fires that would have shown up clearly in charcoal records from lakes and marine sediments. But when Jennifer Marlin and her colleagues analyzed charcoal from 35 sites across North America, they found no spike in burning at the Younger Dryas boundary. Fires had occurred, yes, but they were scattered and sporadic, no different from the background level of natural wildfires. The data simply didn't support the idea of continental conflagration. By 2011, some scientists were writing the obituary for the Younger Dryas impact hypothesis, calling it pseudoscience, comparing it to UFOs and other examples of fringe theories that refuse to die, despite lacking evidence. The hypothesis, they argued, was based on misinterpretation of data, improper methodology, and wishful thinking. The scientific community largely rejected it, and it seemed destined to become a footnote in the history of failed theories. But something interesting happened. The hypothesis didn't die. New research kept appearing, new evidence kept accumulating, and by 2021, some researchers were arguing that the impact event had essentially been confirmed. Studies had found shocked quartz, a mineral deformed by extreme pressure in ways consistent with impact or airburst events, in the Younger Dryas boundary layer. Analysis of sediment cores from the ocean floor detected metallic particles, with compositions consistent with cometary material. Platinum anomalies were documented at multiple sites around the world. In 2023, research at Abu Huraira in Syria found evidence of material melted at temperatures exceeding 2,000 degrees Celsius, hotter than any natural fire could achieve, embedded in the Younger Dryas boundary layer. The melting patterns were consistent with airburst events similar to nuclear explosions. In 2025, analysis of marine sediments from Baffin Bay off Greenland found more evidence of extraterrestrial materials and impact-generated microspherules at the right time level. The debate continues, fierce and unresolved. Mainstream science remains skeptical, pointing to failures to replicate findings and inconsistencies in the data. But the hypothesis has proven more resilient than its critics expected, with new supporting evidence appearing regularly enough to keep it from being dismissed outright. Whether a comet actually struck Earth 12,800 years ago remains an open question, one that may not be definitively answered for years or decades. For Graham Hancock, however, the mere possibility that such an impact occurred is enough to justify investigating what came before, to ask whether an advanced civilization could have existed during the Ice Age and been destroyed by this catastrophe. And that investigation leads him to one site above all others, a place that has become central to his arguments, a place that mainstream archaeology itself admits is deeply mysterious and challenges many assumptions about what prehistoric humans could achieve. That place is Göbekli Tepe, and it might be the most important archaeological discovery of the past century. On a limestone ridge in southeastern Turkey, overlooking the Harran Plain, stands something that should not exist according to our previous understanding of this time period. Massive T-shaped stone pillars, with the largest reaching up to 18 feet tall and weighing as much as 50 tons, arranged in circular enclosures, covered with intricate carvings of animals and abstract symbols, all built approximately 11,600 years ago by people who, according to the conventional timeline, were living as hunter-gatherers without permanent settlements nearby. This is Göbekli Tepe, which translates from Turkish as Belly Hill, and it has become ground zero in the debate about humanity's ancient past. When German archaeologist Klaus Schmidt first excavated the site in 1995, after recognizing limestone fragments that earlier surveys had dismissed as medieval gravestones for what they truly were, pieces of prehistoric megaliths, he knew immediately that he had found something extraordinary. Over the next 2 decades until his death in 2014, Schmidt would uncover enclosure after enclosure, each one a masterpiece of Neolithic engineering and artistry. The oldest structures at Göbekli Tepe date to around 9600 BCE, firmly within the pre-pottery Neolithic period. This was a time when humans had recently transitioned from a purely nomadic lifestyle to semi-sedentary communities, when agriculture was just beginning to develop, when the invention of pottery still lay centuries in the future. The people who built Göbekli Tepe had no metal tools. They had no writing. They had no domesticated animals beyond dogs, no wheels, no pulleys, no evidence of having lived in permanent settlements nearby. Yet somehow, they quarried massive limestone pillars from the bedrock, shaped them with remarkable precision, carved elaborate 3-dimensional reliefs of lions, foxes, wild boars, gazelles, snakes, vultures, and scorpions, transported these multi-ton stones hundreds of meters to the hilltop, erected them upright, and arranged them in complex circular patterns aligned with astronomical phenomena. Then, after using these structures for perhaps 1,000 years, they deliberately buried the entire complex under thousands of tons of fill, preserving it for future ages. The implications are staggering. For decades, the narrative of human civilization had followed a specific sequence. First came agriculture, then permanent settlements, then organized religion and monumental architecture. Society had to become complex before it could afford the labor, organization, and resources necessary to build grand temples. But Göbekli Tepe reverses that sequence. Here was monumental architecture created before agriculture, before permanent settlements, before all the things that were supposed to make such achievements possible. Klaus Schmidt proposed that Göbekli Tepe represented humanity's first temple, a sacred site that attracted people from great distances for religious ceremonies and gatherings. He suggested that the need to repeatedly visit this site to feed the workers who maintained and expanded it may have actually driven the development of agriculture. Instead of settling down, creating civilization, perhaps building this temple created the need to settle down. It was a revolutionary idea, and even mainstream archaeologists who disagreed with Hancock on virtually everything else found themselves reassessing fundamental assumptions about the origins of civilization. For Graham Hancock, Göbekli Tepe was validation. Here was proof that people 12,000 years ago were capable of sophisticated engineering, complex symbolic thinking, and organized labor on a massive scale. If they could build this, what else might they have achieved that we haven't yet discovered? More importantly, where did this knowledge come from? How did hunter-gatherers make such an enormous cognitive and organizational leap, seemingly overnight in the archaeological record? Hancock has pointed to the astronomical alignments he believes are visible in the architecture. The enclosures appear to him to be oriented to specific celestial events, and the carvings on the pillars may, in his interpretation, represent star patterns or a form of astronomical calendar. One pillar, known as the Vulture Stone or Pillar 43, contains imagery that Hancock and some other researchers have interpreted as potentially depicting constellation patterns, though this interpretation remains debated among scholars. Research by Martin Sweatman at the University of Edinburgh has offered one interpretation of these symbols. Sweatman's analysis suggests the symbols carved on Göbekli Tepe's pillars may represent a sophisticated lunisolar calendar system, tracking both the moon's phases and the sun's position throughout the year. If this interpretation is correct, it would make it the oldest known calendar of this type, predating other examples by thousands of years. However, this interpretation is not universally accepted among archaeologists, and alternative explanations for the symbols exist. The construction techniques themselves remain puzzling. The limestone used in the pillars is relatively soft compared to granite or basalt, which makes shaping it easier. But moving stones weighing 50 tons, without beasts of burden, without wheels, without metal tools, would have required ingenuity and effort that strains our understanding of what was possible with Neolithic technology. The T-shape of the pillars appears to be an abstract representation of human form, with arms, hands, and clothing like belts depicted in low relief, suggesting these monuments represented ancestor figures or gods. Most mainstream archaeologists argue that Göbekli Tepe, while impressive and certainly requiring a re-evaluation of some assumptions, doesn't require invoking a lost civilization to explain. They point out that experiments have shown that stone pillars can be quarried, shaped, and moved using simple tools like flint blades, stone hammers, and wooden levers. Large groups of people working together over extended periods could have accomplished what we see without advanced technology. The organization required, they argue, emerged naturally from the social complexity already evident in late Ice Age communities. Recent excavations at Göbekli Tepe have revealed evidence that challenges Schmidt's original interpretation of the site as purely ceremonial, visited by nomads who left no permanent trace. Archaeologists have found domestic structures, water management systems, tools associated with daily life, and significant amounts of processed grain, suggesting the site may have been permanently inhabited by a community that maintained and used the megalithic enclosures. This makes the site more conventional in some ways, less mysterious, but it also raises new questions about how such a community organized itself and sustained its population. But Göbekli Tepe isn't alone. Over the past 2 decades, archaeologists have identified at least 12 similar sites in the same region of southeastern Turkey, collectively known as the Taş Tepeler project. Sites like Karahan Tepe, recently opened to the public, contain their own megalithic structures with unique features, including what appears to be a face carved into the living rock. These sites suggest that Göbekli Tepe was part of a broader cultural network, a shared tradition of monumental architecture and symbolic expression that flourished in Upper Mesopotamia at the end of the Ice Age. For Hancock, these additional sites strengthen his argument. They show that sophisticated building wasn't a one-time fluke, but a widespread capability. He argues that this capability must have come from somewhere, that hunter-gatherers don't spontaneously develop advanced astronomical knowledge and architectural skills without precedent or outside influence. He proposes that survivors of the Ice Age civilization, the one destroyed in the Younger Dryas catastrophe, brought their knowledge to this region, teaching the local inhabitants the skills and knowledge needed to create these monuments as a way of preserving their wisdom and warning future generations about the cosmic catastrophe that had nearly wiped them out. Critics counter that this argument sells humanity short, that it assumes ancient peoples couldn't develop sophisticated capabilities on their own and must have learned from some mysterious benefactor. They point out that there's no evidence of a more advanced predecessor culture in the region, no tools or artifacts that seem out of place for the time period, no clear developmental sequence that would indicate knowledge being transferred from elsewhere. Göbekli Tepe and its related sites appear to have emerged from the local cultural evolution, perhaps accelerated by the challenging conditions following the Younger Dryas cooling. What everyone agrees on is that Göbekli Tepe has fundamentally changed our understanding of what Neolithic peoples were capable of achieving. It has pushed back the timeline for monumental architecture by thousands of years and forced archaeologists to reconsider their models of how civilization developed. Whether it proves the existence of a lost Ice Age civilization remains hotly debated, but it certainly demonstrates that our ancestors 12,000 years ago were far more sophisticated than previous generations of scholars believed possible. And Göbekli Tepe is just the beginning. Because when you start looking at ancient sites around the world with fresh eyes, with the willingness to question whether our understanding of ancient capabilities is complete, you start noticing things that don't quite fit the standard narrative. You notice precision in stonework that seems to exceed what should have been possible with available tools. You notice similarities between cultures that supposedly had no contact. You notice astronomical knowledge encoded in architecture that required centuries of careful observation and mathematical sophistication. And perhaps most puzzling of all, you notice that in many places, the oldest work is often the most impressive, as if builders were working with inherited knowledge that was gradually being lost. Nowhere is this pattern more evident than in the precision stonework found at ancient sites in Egypt and Peru, work that has puzzled researchers for over a century and continues to generate fierce debates about what ancient engineers knew and how they applied that knowledge. These aren't just big stones. These are stones shaped with tolerances, measured in fractions of millimeters, fitted together so precisely that even today you cannot slide a sheet of paper between them, cut with such accuracy that they challenge our assumptions about what can be achieved without modern power tools and measuring instruments. In the deserts outside Cairo, buried beneath the sands for millennia, lies a series of massive granite boxes that few tourists ever see. These are the Serapeum boxes at Saqqara, and they represent one of the most perplexing artifacts from ancient Egypt. According to conventional Egyptology, these boxes were created during the dynastic period, specifically around the reign of Khaemweset in the 13th century BCE, to house the mummified remains of sacred Apis bulls. Massive underground galleries were carved through solid limestone bedrock, with chambers cut to accommodate these enormous granite sarcophagi, each weighing at least 70 tons. But there's a problem, several problems actually, that become apparent when you examine these boxes closely, as engineer Chris Dunn and researcher Brian Forster have done extensively. The boxes are made from Aswan granite, one of the hardest stones used in ancient Egypt, and they display a level of precision that seems impossible for the time period in which they were supposedly created. The interior surfaces are not just smooth, they are flat to within a few thousandths of an inch across their entire surface. The walls are parallel to each other, the corners are square. The tolerances are what a modern machinist would call precision work. Chris Dunn, who has spent decades working in the aerospace industry, manufacturing complex metal parts, knows what precision looks like. When he measured the Serapeum boxes with precision instruments, he reported finding that the internal surfaces met tolerances he considers remarkable for ancient work. More perplexingly, the lids of the boxes were cut from the same block of granite as the boxes themselves, meaning a single massive stone was somehow hollowed out with what he describes as extraordinary precision. How was this done? The conventional answer is that ancient Egyptian workers used copper or bronze tools along with the abrasive sand to slowly grind away the granite over many years. While copper and bronze are softer than granite and cannot cut it directly, using harder abrasive materials like quartz sand between the tool and the granite can wear away the stone. This is painstaking work requiring enormous effort and time, but it's possible. Experiments have shown it can be done. Yet when you look at the sheer number of precision artifacts in ancient Egypt, when you calculate the man-hours that would have been required to create them all using these primitive methods, the numbers start to seem implausible. You're talking about tens of thousands of hours per object, requiring crews of skilled workers maintaining consistency over decades. And you're left with the question, why? Why would ancient Egyptians invest such enormous resources to create burial chambers for bulls, no matter how sacred, with tolerances that far exceed what would be necessary or even visible? Some researchers, including Hancock, suggest that the Serapeum boxes weren't created by the dynastic Egyptians at all, but are remnants of an earlier, more technologically sophisticated culture. They point out that nowhere in Egyptian texts or artwork is there any depiction of how these boxes were made or moved into position. They argue that the precision is so high that it suggests knowledge of geometry and measurement far beyond what we attribute to Bronze Age peoples. They speculate that the dynastic Egyptians found these boxes already in place and repurposed them for their own burial rituals. But the Serapeum boxes aren't the only puzzling precision work in Egypt. Throughout sites like Giza, Abu Sir, and Saqqara, you find evidence of remarkable drilling and soaring capabilities. Circular holes drilled through hard granite and basalt, some of which, according to calculations by certain modern engineers, appear to have removed material at rates that seem difficult to explain with hand-powered copper tools and abrasives alone. Saw marks in granite blocks showing what some interpret as evidence of cuts that removed material efficiently. One famous example is the unfinished obelisk at the Aswan quarry. This massive piece of granite, if completed, would have stood 140 feet tall and weighed over 1,200 tons. The obelisk was never finished because cracks developed in the stone, but what it shows us is fascinating and troubling. The marks left by the tools used to separate this obelisk from the bedrock show a level of control and capability that seems to require more than just pounding with stone hammers, yet no tools capable of doing this work have ever been found. Then there are the precision stone vessels. Thousands of them have been found in Egypt, many predating the dynastic period, made from the hardest stones available: diorite, granite, basalt. These vessels display remarkably symmetrical curved surfaces and uniform wall thickness, with internal chambers accessed through narrow necks. When some modern engineers examine these artifacts, they express puzzlement about how such precision was achieved, with the tools conventionally attributed to their makers. Halfway around the world in Peru, we find similar puzzles. The massive stones of Sacsayhuamán, the fortress complex overlooking Cusco, display the same inexplicable precision. Some of these blocks weigh over 200 tons, and they're fitted together with such accuracy that you literally cannot insert a knife blade between them. The stones aren't rectangular blocks stacked in neat rows. They're irregular polygonal shapes, each one unique, each one somehow precisely matched to its neighbors to create walls that have stood for centuries, surviving earthquakes that destroyed more recent structures built around them. The official explanation is that Incan masons used stone hammers to pound the blocks into shape, constantly lifting them into place and removing them to chip away high spots until they achieved a perfect fit. This trial and error method was demonstrated by archaeologist Jean-Pierre Protzen, who successfully created some precision-fitted stones using these traditional techniques. But Protzen himself noted limitations to this method, particularly when working with the hardest andesite stones found at sites like nearby Ollantaytambo and distant Puma Punku in Bolivia. At Ollantaytambo, you find blocks of rose-colored rhyolite, a volcanic stone harder than granite, fitted with the same precision as at Sacsayhuamán. More puzzling, these stones were quarried from a site on the other side of a deep river valley, transported across difficult terrain, then somehow lifted into place on a steep mountainside. The logistics of moving 200-ton stones across this landscape strain credulity even with modern equipment. With only fiber ropes, wooden levers, and human muscle power, it approaches impossibility. But perhaps one of the most perplexing ancient sites is Puma Punku in Bolivia. Part of the larger Tiwanaku complex, Puma Punku contains stones cut with remarkable precision. There are 8 shaped blocks, with some estimated to weigh over 100 tons, that appear to have been created as modular, interlocking components. The surfaces are flat to tolerances measured in fractions of millimeters. The angles are exact 90-degree corners that would challenge modern stone cutters. And most mysteriously, there are drill holes that seem to have been made with some kind of advanced bit, cutting through hard andesite with uniform depth and clean edges. Researchers Jean-Pierre Protzen and Stella Nair, who conducted extensive studies of Tiwanaku stonework, concluded that to achieve the precision visible at Puma Punku, ancient builders must have used techniques unknown to the later Incas and unknown to us today. They write that the perfectly planar surfaces, the exact right angles, the sophisticated decorative details could not have been made with hammerstones alone. Something else was involved, but what that something was remains a mystery, since no tools capable of this work have been found at the site. This is where alternative researchers like Hancock, Christopher Dunn, and Brian Forster step in with speculation that goes beyond conventional archaeology. Some propose that ancient peoples had access to advanced tools that we haven't discovered or recognized. Perhaps they had harder cutting materials than we've given them credit for. Perhaps they knew techniques for working stone that we've forgotten. Perhaps they had chemical or sonic methods of softening or cutting stone that wouldn't leave obvious tool marks. These theories often invoke copper tube drills armed with diamond-hard abrasives, potentially even jewels set into the cutting surface. They suggest the possibility of ultrasonic drilling, where high-frequency vibrations combined with abrasive paste could cut through hard stone more efficiently than mechanical force alone. Some researchers even suggest more exotic possibilities: the use of focused solar energy to heat and weaken stone, chemical softening agents derived from plants, or sound frequencies that could fracture stone along desired planes. The problem with all these alternative explanations is the lack of direct evidence. No ancient high-tech tools have been found, no chemical residues that would indicate stone softening compounds, no ultrasonic generators carved from stone or cast in metal. The tools that have been found at ancient sites are exactly what you'd expect: simple copper or bronze implements, stone hammers, abrasive materials. Nothing that suggests capabilities beyond what mainstream archaeology attributes to ancient peoples. Yet the precision remains, the tolerances remain. The inexplicable efficiency with which massive amounts of hard stone were removed remains. And this creates a fundamental tension between what we can see and what we can explain. Either ancient peoples achieved these results using simple tools and enormous effort, which experiments show is possible, but would require resources and timescales that seem improbable, or they had capabilities we don't understand, which would require revising our understanding of ancient technology, but lacks direct supporting evidence. There's a third possibility that doesn't get discussed as often: that some of this precision work, particularly in Egypt and Peru, predates the cultures we attribute it to. That the oldest and most impressive stonework was already ancient when the historical Egyptians and Incas arrived. That these later cultures found it, marveled at it, and attempted to emulate it with less success. Which is why we often see a decline in quality over time at these sites. This is where Hancock's theory of a lost civilization providing knowledge to later cultures becomes relevant. If sophisticated stone-working techniques were taught by survivors of an Ice Age civilization to the ancestors of the Egyptians and various Andean peoples, it might explain why the oldest work is often the best, why similar techniques appear on different continents, and why no clear developmental sequence leading to these capabilities is evident in the archaeological record. The knowledge was imported, not developed locally, and as centuries passed, it was gradually forgotten or corrupted. The counterargument is that this theory is unnecessary, that attributing unexplained artifacts to a lost civilization is intellectually lazy, a way of avoiding the hard work of figuring out how ancient peoples actually accomplished their feats. That the similarities between Egyptian and Peruvian stonework are superficial, that the techniques used were actually quite different, despite appearing similar to untrained eyes. That the presumed decline in quality over time can be explained by changing priorities, available resources, and shifting cultural values rather than forgotten knowledge. Both sides make valid points, and the truth likely contains elements of both perspectives. Ancient peoples were clearly more capable than many early archaeologists assumed. Experiments have demonstrated that much of what seemed impossible can actually be achieved with period-appropriate tools, given enough time and effort. But equally clearly, there are aspects of ancient engineering that remain poorly understood. Techniques that we cannot fully replicate even with modern equipment. Precision that seems excessive for its purpose, and therefore suggests either aesthetic motivations we don't appreciate or practical requirements we don't understand. What's needed isn't more speculation, but more careful research. Detailed examination of tool marks at the microscopic level to determine exactly what kinds of tools created them. Replication experiments that don't just show what's possible, but calculate realistic timeframes and resource requirements. Investigation into whether there are patterns in the precision work that might reveal organizing principles or templates that guided ancient engineers. Archaeological methodology has evolved significantly over the past century. Early archaeologists often worked quickly, removing artifacts from their context without careful documentation. Modern archaeology treats excavation sites like crime scenes, meticulously recording the exact position of every object, analyzing soil samples, employing ground-penetrating radar and LiDAR to map sites before digging begins. Each layer of earth tells a story about who lived there, when they lived, what they ate, how they worked, and how their society changed over time. Dating techniques have become increasingly sophisticated. Radiocarbon dating, which measures the decay of carbon-14 in organic materials, can provide dates accurate to within decades for materials up to 50,000 years old. Optically stimulated luminescence measures when minerals like quartz were last exposed to sunlight, useful for dating pottery and burned materials. Dendrochronology uses tree ring patterns to date wooden structures with precision down to the individual year. Each technique has limitations and potential sources of error, which is why archaeologists typically use multiple methods to cross-check their findings. The field also benefits from advances in other sciences. Genetic analysis of ancient remains reveals population movements, relationships between groups, and even information about diet and disease. Isotope analysis of teeth can indicate where someone grew up based on the minerals they ingested as a child. Chemical analysis of pottery residues tells us what people cooked and stored. Pollen analysis reveals what plants grew in the area at different times, indicating climate changes and agricultural practices. This scientific rigor is what makes archaeology reliable, but it also means that conclusions must be based on evidence that can be measured, tested, and replicated. Speculation has its place in generating hypotheses, but those hypotheses must then be tested against physical evidence. This is where alternative theories often struggle. Not because mainstream archaeology is dogmatic, but because the theories don't generate testable predictions, or the predictions fail when tested. And perhaps most importantly, we need to remain open to evidence that challenges our assumptions while maintaining rigorous standards for what counts as evidence. The precision stonework at ancient sites is real. The questions it raises are legitimate. But questions don't equal answers, and mysteries don't equal impossible. The challenge is distinguishing between what is genuinely anomalous and requires new explanations, and what merely seems anomalous because we don't yet understand it fully. That line can be difficult to identify, especially when the stakes are high and reputations are on the line. What cannot be dismissed, what should fascinate anyone interested in human history, is that ancient peoples around the world created works of such skill and beauty that they still impress us thousands of years later. Whether they did it with techniques we understand or techniques we've forgotten, they left monuments that speak to human capability, determination, and ingenuity. And scattered among these monuments are genuine anomalies, things that don't fit easily into our narratives, that suggest our understanding remains incomplete. Those anomalies deserve investigation, not dismissal. But stone precision is just one piece of the puzzle that Hancock has assembled over his decades of research. Because even more intriguing than how ancient peoples worked stone is the question of why so many distant cultures, separated by vast oceans and supposed millennia of independent development, created structures that are so similar. Why do pyramids appear in Egypt, Mexico, Peru, China, and Indonesia? Why do so many ancient sites align with the same celestial bodies? Why do flood myths appear in virtually every culture on Earth? These similarities, Hancock argues, point to something deeper than coincidence or convergent evolution. They point to shared knowledge, to a common source that preceded and influenced all these later civilizations. Walk into any major museum with ancient collections, spend time examining artifacts from different cultures separated by thousands of miles, and you'll start noticing something peculiar. The pyramid shape appears again and again. Not just the iconic triangular pyramids of Egypt, but stepped pyramids, truncated pyramids, pyramids of earth and pyramids of stone, pyramids used for burials and pyramids used for ceremonies, pyramids aligned to cardinal directions, and pyramids aligned to significant celestial events. From the Americas to Africa to Asia, the pyramid form shows up with striking regularity. Now, mainstream archaeology has a straightforward explanation for this. The pyramid or stepped structure is a natural architectural form that different cultures arrived at independently because it's stable, practical, and impressive. When you want to build something tall without advanced engineering, you stack progressively smaller layers. The result is naturally pyramidal. It's convergent evolution in architecture, similar to how wings evolved independently in insects, birds, and bats because flight demands certain structural solutions. But Graham Hancock looks at the specific details and sees something more intentional, more connected. He points out that many of these pyramid structures, despite being separated by oceans and thousands of years, share characteristics that go beyond simple stability. They're often precisely aligned to the cardinal directions with accuracies that require sophisticated surveying. They incorporate astronomical alignments to solstices, equinoxes, and significant stars. They use similar construction techniques, particularly the use of massive foundation stones supporting smaller upper structures. And they appear in the myths of their respective cultures as having been built by gods or culture heroes who brought knowledge from a distant land. Consider the Great Pyramid of Giza, built approximately 4,500 years ago. Its four sides are aligned to the cardinal directions with remarkable precision, with an error of less than 4 minutes of arc, an accuracy that requires careful astronomical observation and sophisticated measurement techniques. The pyramid's dimensions have been noted by researchers to encode interesting mathematical relationships. The ratio of its perimeter to its height approximates 2 times pi. Whether this was intentional or coincidental remains debated among scholars. Its internal passages align with specific stars as they would have appeared in the night sky at the time of construction, particularly the star Sirius and stars in Orion's belt. Now, travel to Mexico and examine the pyramids at Teotihuacan, built around 2,000 years ago. The Pyramid of the Sun appears to be aligned so that on 2 days of the year, May 19th and July 25, the sun passes directly overhead at noon. The entire complex is oriented to a baseline 15.5 degrees east of true north. Some researchers have suggested this baseline may have been chosen to align the pyramids with certain peaks on the horizon where the Pleiades star cluster would have set in antiquity, though this interpretation is debated. The mathematical relationships between the sizes of different structures suggest deliberate planning using consistent measurement systems. Cross the Pacific to China, and you find the massive tomb pyramids of the early emperors, some rivaling Giza in size, all oriented to cardinal directions. In Cambodia, the temples of Angkor Wat incorporate precise alignments to equinox sunrise and encode astronomical cycles in their architectural proportions. In Indonesia, Gunung Padang consists of massive stone columns arranged in terraces, while some controversial claims have suggested it could date back over 20,000 years. These dates are highly disputed and not accepted by mainstream archaeology, with most researchers dating the visible structures to a much more recent period. Back in the Americas, the stepped pyramids of the Maya, the massive earthen mound at Cahokia in North America, the complex of pyramids at Caral in Peru, dating back nearly 5,000 years. Each one shows evidence of astronomical knowledge encoded in orientation and proportion. The Maya in particular developed arguably the most sophisticated calendar system of any ancient culture, tracking Venus cycles, eclipse patterns, and creating accurate calculations of the solar year that would have required centuries of patient observation. To Hancock, this pattern suggests a diffusion of knowledge, a transfer of information from a common source to distant peoples. He proposes that the Ice Age civilization had developed advanced astronomy and sophisticated mathematics, and that when survivors of the Younger Dryas catastrophe scattered across the globe seeking refuge, they brought this knowledge with them. They taught local peoples about the movements of the heavens, the importance of precise alignments, the relationships between geometry and astronomy. Over generations, this knowledge was adapted to local conditions and beliefs, but the core principles remained recognizable. Critics respond that this vastly underestimates human capacity for independent innovation. They point out that astronomy is naturally important to agricultural societies who need to track seasons for planting and harvest. That cultures living under the same sky will notice the same celestial phenomena and might arrive at similar ways of marking them. That the cardinal directions are obvious reference points visible to anyone with a horizon and the sun. That mathematical relationships like pi emerge naturally from practical measurement and construction tasks, not from some inherited wisdom. The debate becomes more interesting when we look at specific similarities that are harder to explain through convergence. For instance, the use of massive polygonal stonework appears in both Peru and Easter Island, locations separated by thousands of miles of ocean. Both locations also feature similar megalithic statuary, the Moai of Easter Island, and the less famous but equally impressive statues at Tiwanaku. Both cultures practiced cranial deformation, intentionally shaping infants' skulls for aesthetic or social reasons, a practice that also appears in ancient Egypt and other far-flung locations. Even more intriguing are some of the linguistic and mythological parallels noted by researchers. The word for sun shows interesting similarities across some languages. Ra in ancient Egyptian, Inti in Quechua, Ra in Sanskrit. Whether these similarities represent actual historical connections, borrowing, or coincidence remains a topic of scholarly discussion. The flood myth appears in numerous ancient cultures. Mesopotamian epics like Gilgamesh, in the biblical account of Noah, in Hindu texts describing Manu, in Chinese legends of Gunyu, in Aztec stories of the destruction of previous worlds, in Aboriginal Australian Dreamtime narratives, in Polynesian legends across the Pacific. The details vary significantly, but stories involving catastrophic floods appear across many cultures. Whether this represents shared memory of actual events, independent responses to local flooding, or universal human anxieties about water and disaster, has been debated by scholars. Now, some of this can be explained without invoking a lost civilization. Catastrophic floods happen naturally and would have been terrifying events for ancient peoples, becoming embedded in their mythologies. Languages can borrow words through trade contacts, even across great distances. Similar environments produce similar cultural responses. But when you look at the totality of similarities, when you see astronomical knowledge, architectural techniques, mythological themes, and even genetic evidence all pointing in the same direction, the question of whether some form of knowledge transfer occurred becomes harder to dismiss outright. Recent genetic research has added complexity to this discussion. Studies of ancient DNA have revealed that human populations were more mobile during prehistory than many previously believed. Genetic studies have found evidence suggesting contact between Polynesian and Native American populations, indicating ancient transoceanic interactions. The timing and nature of these interactions continue to be studied and debated. Australasian genetic markers appear in some Amazon populations, with research suggesting these could date back thousands of years. The mechanism and timing of how such distant populations might have exchanged genetic material remains an active area of research, with various hypotheses being investigated. Hancock points to these genetic findings as evidence that his proposed scenario is at least plausible. If ancient peoples were capable of transoceanic voyages, if they were mixing genetically across continents, then the transfer of knowledge and cultural practices between distant regions becomes possible, perhaps even likely. The survivors of his proposed Ice Age civilization wouldn't have needed to visit every location. They could have taught a few groups, who then migrated and spread the knowledge further over generations. Another line of evidence that Hancock emphasizes is the similarities in how various ancient cultures described their own origins. The ancient Egyptians spoke of Zep Tepi, the first time, an age when gods walked the earth and established civilization. They described 7 sages who brought wisdom and knowledge. In Mesopotamia, the Apkallu were 7 sages who came from the sea before the Great Flood to teach humanity. In India, the 7 rishis performed a similar role. In Mesoamerica, Quetzalcoatl and Viracocha were culture heroes who appeared after a great catastrophe to teach agriculture, astronomy, and moral law. These myths share a common structure. There was a golden age. It was destroyed by catastrophe. Survivors or gods came to help humanity rebuild, and they left behind knowledge encoded in monuments and texts. To Hancock, these aren't just stories. They're memories, distorted by time and mythologized, but retaining kernels of historical truth. The catastrophe was the Younger Dryas impact. The survivors were the remnants of the Ice Age civilization. The knowledge they brought was real astronomical and architectural expertise. The monuments they inspired are the pyramids, temples, and megalithic structures we still marvel at today. Mainstream archaeologists offer a different interpretation. These myths reflect universal human concerns about order versus chaos, the fear of disaster, the desire for divine guidance, the need to explain the existence of ancient ruins whose builders had been forgotten. They're archetypes that emerge independently because they address fundamental human anxieties and questions. The similarities don't prove contact or shared origin. They prove shared humanity, shared psychology, shared ways of making sense of a frightening and uncertain world. But here's where the debate gets particularly contentious. Who gets to claim credit for the achievements of ancient civilizations? When Hancock suggests that megalithic construction and sophisticated astronomy were taught to ancient peoples by survivors of a lost civilization, his critics accuse him of diminishing the accomplishments of indigenous peoples, of essentially saying that Egyptians, Maya, Incans, and others couldn't have figured these things out on their own and needed outside help. This criticism stings particularly when the lost civilization is vaguely described and often implicitly assumed to be more advanced, more sophisticated, more capable than the actual historical cultures whose achievements are being questioned. Indigenous groups have explicitly pushed back against Hancock's theories. When he planned to film parts of the second season of Ancient Apocalypse in the United States, Native American communities opposed it, arguing that his narrative disrespects their ancestors by attributing their achievements to mysterious outsiders. This opposition led to the cancellation of some planned filming. Critics point out that this pattern, attributing indigenous accomplishments to lost civilizations, ancient aliens, or other external sources, has a long and troubling history tied to racism and colonialism. Hancock responds that he's not attributing accomplishments to outsiders, but rather acknowledging that knowledge can be shared between cultures, that human history is one of constant interaction, migration, and exchange. He argues that recognizing possible influences from an earlier civilization doesn't diminish later cultures any more than acknowledging that European Renaissance scholars learned from ancient Greek and Roman texts diminishes European achievement. Knowledge builds on knowledge. Civilization isn't created in isolation. But this defense doesn't fully address the concern, because Hancock's theory does implicitly suggest that certain achievements, particularly those that he finds most impressive or mysterious, required outside knowledge to accomplish. The baseline assumption seems to be that if something appears too advanced for its time, it must have been influenced by the lost civilization, rather than representing the peak of what that culture could achieve through its own innovation and effort. This is where the accusation of cherry-picking becomes most relevant. When archaeologists point to the clear developmental sequences visible at most ancient sites, showing how techniques evolved over time through trial and error, when they demonstrate that most of what seems mysterious can be explained through known methods and available tools, Hancock tends to focus on the outliers, the exceptional cases that don't fit neat explanations. But if you're always looking for anomalies, you'll find them even in datasets that are otherwise well understood. The question is whether these anomalies represent genuine mysteries requiring new theories, or whether they're simply the tail end of the bell curve, the exceptional cases that every large sample produces. This brings us to what might be the most fundamental question in the entire debate. What counts as evidence, and what standards should we apply when evaluating extraordinary claims? Because make no mistake, Hancock is making an extraordinary claim. He's proposing that a sophisticated Ice Age civilization existed, was destroyed by a cosmic catastrophe, and influenced all later civilizations, despite leaving behind no cities, no clear artifacts, no written records, and no unambiguous archaeological proof of its existence. This is, by any measure, a claim that requires extraordinary evidence to be accepted by the scientific community. And whether that evidence exists, whether the patterns Hancock identifies are sufficient to overturn decades of archaeological consensus, is where reasonable people disagree most strongly. When you step back from the specific arguments and examine the broader debate between Graham Hancock and mainstream archaeology, what you're really witnessing is a clash between two different approaches to understanding the past, two different standards for what constitutes acceptable evidence, and perhaps most fundamentally, two different philosophies about the nature of scientific inquiry itself. This isn't just an argument about whether a lost civilization existed. It's an argument about how we know what we know, about the role of skepticism versus open-mindedness, about the balance between following evidence and questioning assumptions. The scientific method, as practiced in archaeology and related disciplines, is built on certain principles. Claims require evidence, and extraordinary claims require extraordinary evidence. Hypotheses should be testable and falsifiable. When multiple explanations fit the available data, the simplest explanation that requires the fewest unproven assumptions is generally preferred. This is Occam's razor, and it's a powerful tool for avoiding unnecessarily complicated explanations. Researchers should follow the evidence where it leads, but they should also be skeptical of their own conclusions and actively look for ways they might be wrong. By these standards, Hancock's theory struggles. It proposes the existence of a civilization for which we have no direct evidence, no cities, no clear artifacts that couldn't belong to known cultures, no unambiguous proof. It requires invoking a global catastrophe for which the evidence is contested at best. It interprets similarities between distant cultures as evidence of contact or shared origin, when simpler explanations, convergent evolution and parallel development, can often account for these similarities. It cherry-picks evidence, critics argue, focusing on mysteries and anomalies while ignoring the vast body of archaeological data that fits conventional timelines and explanations. Hancock's defenders, and Hancock himself, respond that the scientific method as practiced by mainstream archaeology has become calcified, that it rejects evidence that doesn't fit established paradigms, that it protects consensus rather than pursuing truth. They point to examples from the history of science where revolutionary ideas were initially rejected. Continental drift, meteorite impact craters as geological features, the antiquity of human presence in the Americas. In each case, establishment scientists resisted new theories because they contradicted accepted wisdom until accumulating evidence forced a paradigm shift. Could the same pattern be playing out with the lost civilization hypothesis? Is this a case where future archaeologists will look back and wonder why it took so long to accept what now seems obvious? Or is it more like the countless failed theories that litter the history of science? Ideas that seemed compelling to their proponents but ultimately couldn't be sustained when subjected to rigorous testing. The strongest criticism leveled at Hancock is that he cherry-picks his evidence. He focuses on the sites, artifacts, and data points that fit his theory, while ignoring or downplaying everything that contradicts it. When archaeologists point to clear developmental sequences showing how ancient cultures evolved their capabilities over time, Hancock dismisses this as the mainstream narrative protecting itself. When experiments demonstrate that ancient peoples could have accomplished their feats with available technology, he argues the experiments don't capture the full scale of what was achieved. When dating methods show that structures were built when conventional history says they were, he questions the dating methods or suggests that older structures were later modified. This selective use of evidence is problematic because it makes the theory unfalsifiable. Any evidence against it can be dismissed as part of the mainstream cover-up or as missing the point. Any evidence that might support it, no matter how ambiguous, is championed as proof. This is not how good science works. A robust theory must make specific predictions that can be tested. It must be capable of being proven wrong if the predictions fail. Hancock's theory seems designed to accommodate any configuration of evidence, which makes it intellectually satisfying to its believers, but scientifically weak. Take the issue of the Younger Dryas impact hypothesis, which is central to Hancock's scenario. When the hypothesis was first proposed in 2007, it made specific, testable predictions. There should be a distinct layer of impact markers across much of the planet. There should be evidence of continent-scale wildfires at the right time. There should be sudden changes in climate, extinctions, and cultural disruptions coinciding with the impact date. These are testable predictions, and over the past 17 years, they've been tested extensively. The results are mixed at best. Some researchers report finding the predicted impact markers. Others sampling from the same time period find nothing. The evidence for massive wildfires hasn't materialized in most fire history reconstructions. The cultural and population disruptions claimed to have occurred show up inconsistently in archaeological data, with some regions showing changes and others showing continuity through the Younger Dryas period. When research fails to confirm predictions, proponents of the impact hypothesis either argue that the methods were flawed or shift the hypothesis slightly to accommodate the negative results. This is frustrating for mainstream scientists because it makes productive debate difficult. How do you falsify a theory that keeps adapting to avoid falsification? How do you argue with someone who, when you demonstrate that their claimed evidence doesn't hold up to scrutiny, simply moves on to the next claimed piece of evidence without acknowledging that their case has weakened? This is why many archaeologists have simply stopped engaging with Hancock's arguments directly. They see it as unproductive, as playing a game where the rules keep changing to ensure one side can never lose. But Hancock and his supporters have legitimate grievances too. They point out that mainstream archaeology doesn't always practice the open-minded skepticism it preaches. When anomalies are discovered, when dates don't fit expectations, when artifacts seem out of place, there's sometimes a tendency to dismiss or explain away these findings rather than take them seriously. Young researchers who pursue unconventional theories risk their careers. Funding tends to go to projects that reinforce rather than challenge existing paradigms. The peer review system can serve as a gatekeeping mechanism that protects orthodox views from challenge. There's a tension in any scientific field between maintaining rigorous standards and remaining open to new ideas. If you set the bar for evidence too low, you end up accepting every crackpot theory that comes along. If you set it too high, you risk missing genuine discoveries because they don't fit your preconceptions. Getting this balance right is difficult, and different people will draw the line in different places based on their temperament, their training, and their assessment of the evidence. What's clear is that the current situation, where Hancock and mainstream archaeologists talk past each other rather than to each other, benefits no one. Hancock reaches massive audiences through his books and documentaries, introducing millions of people to questions about ancient history. Some of those people will be inspired to learn more, to study archaeology themselves, to contribute to our understanding of the past. Others will come away with distorted views, believing that archaeologists are closed-minded dogmatists, hiding the truth, or that ancient achievements can't be explained without invoking lost civilizations or ancient aliens. Meanwhile, mainstream archaeologists see their life's work dismissed or misrepresented, their careful scholarship characterized as dogma, their reasoned objections portrayed as defensiveness. They see the public turning to charismatic presenters rather than expert scholars, with platforms like Netflix giving uncritical airtime to theories that wouldn't survive peer review. They worry about the erosion of trust in expertise, about the post-truth environment where compelling narratives trump careful evidence, about the real damage that pseudoscience can do to public understanding. Both sides have valid concerns, and both sides could do better. Hancock could be more rigorous about distinguishing what's proven from what's speculative, about acknowledging evidence that contradicts his theories, about presenting mainstream archaeology's views fairly rather than as straw men to knock down. Mainstream archaeologists could be more willing to engage with anomalies, to communicate their findings in accessible ways that compete with popular media, to acknowledge uncertainties and gaps in current understanding, rather than presenting a false certainty. Because the truth is, there's a lot we don't know about ancient history. Our picture of the past is built from fragmentary evidence, educated guesses, and assumptions that may or may not be correct. Archaeological sites are excavated and interpreted through the lens of contemporary theories, which means that evidence that doesn't fit current paradigms might be overlooked or misinterpreted. And the further back you go in time, the less evidence survives, the more speculative interpretations become, and the more room there is for legitimate disagreement. Consider what we've learned in just the past few decades. We now know that humans were in the Americas far earlier than previously believed, with footprints at White Sands in New Mexico dated to between 21,000 and 23,000 years ago, during the last glacial maximum, when much of North America was supposedly uninhabitable. We know that Neanderthals were far more sophisticated than portrayed in the past, with evidence of symbolic behavior, art, and possibly even religion. We know that massive underwater structures like Doggerland once existed, entire landscapes now submerged that were home to populations we know almost nothing about. Each of these discoveries required archaeologists to revise their timelines and theories, not because they were covering up evidence or protecting dogma, but because new evidence came to light that changed the picture. This is how science is supposed to work. But it also means that current consensus, while based on the best available evidence, is provisional, subject to revision as new discoveries are made. Certainty about the ancient past is always tentative. So where does this leave us on the question of Graham Hancock's lost civilization theory? If we're being honest, it leaves us with more questions than answers. Are there genuine anomalies in the archaeological record that deserve more attention than they've received? Almost certainly yes. Do these anomalies require invoking a lost Ice Age civilization to explain? Almost certainly no, at least not based on the evidence currently available. Could future discoveries change this assessment? Possibly, but only if those discoveries meet rigorous standards and can't be explained more simply through known mechanisms. What Hancock has done, whatever his faults, is keep alive a sense of mystery and wonder about the ancient past. He's reminded millions of people that history is not a closed book, that there are still discoveries to be made, questions to be answered, and that our ancestors were capable of extraordinary things. If his theories motivate even a few people to pursue serious study of archaeology, to bring fresh perspectives and new questions to the field, that's valuable. But it comes with a responsibility to be honest about what's known versus what's speculated, to represent opposing views fairly, and to acknowledge when evidence doesn't support cherished theories. The debate will continue, probably for decades to come, because at its core, it's not just about whether one specific theory is correct. It's about how we investigate the past, what standards we apply, how we balance skepticism with openness, and how we communicate about these issues to a public that's increasingly distrustful of expertise, but hungry for meaning and connection to our deep history. These are questions worth grappling with, even if the answers remain elusive. And as archaeology continues to make new discoveries, as analytical techniques improve, as more of the past is gradually revealed, we'll get closer to understanding what really happened in those distant ages when humanity first began building the monuments and creating the knowledge that we still marvel at today. As we've journeyed through Graham Hancock's theories, examining the evidence he presents and the criticisms leveled against him, we've encountered some genuinely puzzling aspects of the ancient world. Regardless of whether you accept his lost civilization hypothesis, there are real discoveries being made right now that are reshaping our understanding of human capability and history. These aren't the stuff of speculation or controversy. They're documented, peer-reviewed findings that mainstream archaeology itself acknowledges as significant, even revolutionary. And they're worth examining because they show that questioning our assumptions about the past isn't pseudoscience. It's the foundation of good archaeology. Take Göbekli Tepe, which we discussed earlier. Since Klaus Schmidt's initial excavations, the site continues to yield surprises. Recent work has identified evidence of permanent settlement that challenges earlier interpretations of the site as purely ceremonial. Researchers have found grinding stones for processing grain, storage structures, and domestic waste in quantities that suggest sustained habitation. This doesn't make the site less mysterious. If anything, it makes it more impressive. It means that people were not just visiting to perform rituals, but living there year-round, organizing themselves in ways that required social complexity we didn't think existed yet. And Göbekli Tepe isn't unique anymore. The broader Taş Tepeler project has now identified more than a dozen similar sites in the region. Karahan Tepe, recently opened to excavation, contains its own massive megalithic structures, including what appears to be a face carved into the living rock, emerging from walls covered in symbolic reliefs. These sites suggest an entire culture, a widespread tradition of monumental building and symbolic expression that flourished in southeastern Anatolia 11,000 years ago, and then, mysteriously, stopped. The sites were deliberately buried, and the tradition they represented apparently didn't continue. Why did this happen? What caused this civilization, and it was a civilization by any reasonable definition, to abandon these massive construction projects and bury them? Mainstream archaeology doesn't have a complete answer, and speculation about climate change or social upheaval remains just that: speculation. It's a genuine mystery, and while you don't need to invoke Hancock's lost civilization to acknowledge it, neither can you dismiss it as simply explained. Similarly, underwater archaeology continues to make discoveries that push back the timeline of human achievement. Off the coast of India near Dwarka, divers have found what appear to be worked stone structures beneath the sea, though dating and interpretation remain contentious. Off Japan, the Yonaguni Monument, a massive rock formation featuring what look like straight edges, right angles, and terraced levels, has been argued by some to be artificial, though most geologists maintain it's a natural formation shaped by erosion. The debate continues. In the Mediterranean, entire ancient harbors and settlements have been found submerged, victims of rising sea levels or geological subsidence. These weren't just coastal villages, but sophisticated port cities with warehouses, seawalls, and maritime infrastructure. How many other sites remain undiscovered beneath the waves? We know that sea levels at the end of the Ice Age were more than 300 feet lower than today. Entire coastlines, valleys, and plains that were home to human populations are now underwater. The archaeological record is necessarily incomplete because we can't easily access huge portions of where ancient peoples lived. Recent genetic studies have also complicated the picture of human history. Ancient DNA reveals population movements and mixtures we had no idea occurred. The discovery of Australasian genetic signatures in Amazon peoples dating back 10,000 years suggests long-distance migrations across the Pacific that we have no historical record of. How did they travel those distances? What knowledge and technology did they possess that allowed such voyages? We don't know, but clearly our ancestors were more mobile and more capable than we often assume. In the Americas, sites keep pushing back the date of human arrival. For decades, the Clovis culture, dating to about 13,000 years ago, was considered the first human presence in the New World. Then older sites were found, and the dates kept moving backward. The footprints at White Sands National Park in New Mexico, dated to between 21,000 and 23,000 years ago, show humans were present during the last glacial maximum, when most of North America was supposedly covered in ice sheets and uninhabitable. How did they get there? How did they survive? What else don't we know about this earliest chapter of American history? In Egypt, new excavation techniques and modern analysis are revealing details about ancient construction that earlier archaeologists missed. Microanalysis of tool marks on granite surfaces shows that multiple different techniques were used, some of which we still don't fully understand. Traces of copper in deep drill holes suggest that bronze or copper tools were employed, but the efficiency with which they removed hard stone still puzzles engineers. Ground-penetrating radar at sites like Saqqara continues to reveal buried structures we didn't know existed, suggesting that much of ancient Egypt literally remains hidden, waiting to be discovered. The Sphinx, that enigmatic monument that has stood guard over the Giza Plateau for millennia, continues to generate debate about its age and purpose. While mainstream Egyptology dates it to the reign of Khafra around 2500 BCE, some researchers, notably Robert Schoch and John Anthony West, have proposed based on erosion patterns that the structure could be much older, potentially dating back 7,000 to 9,000 years when rainfall in Egypt was more abundant. This theory remains highly controversial and is rejected by most Egyptologists, who offer alternative explanations for the erosion patterns. In Peru and Bolivia, new research using LiDAR technology is revealing hidden structures beneath the jungle canopy. Sites we thought we understood turn out to be part of much larger complexes. The extent of ancient earthworks in the Amazon basin, visible only from the air or through remote sensing, suggests that pre-Columbian populations in South America were far larger and more organized than previously believed. Hundreds of geometric earthworks, massive ditches and embankments forming circles and squares, demonstrate planning and labor organization on an impressive scale. These earthworks are often aligned to astronomical events, particularly solstices, showing that ancient Amazon peoples possessed sophisticated knowledge of celestial cycles. The Terra Preta, or Black Earth, found across the Amazon is now understood to be deliberately created by indigenous peoples through a sophisticated understanding of soil science, creating supersoil that remains fertile centuries later. Far from primitive hunter-gatherers living lightly on the land, it's now clear that the Amazon was home to advanced civilizations, with deep knowledge of their environment. All of these discoveries and countless others being made every year demonstrate that the story of human civilization is more complex, more interesting, and more surprising than textbooks written even 20 years ago suggested. We keep underestimating our ancestors, assuming they were more primitive, less capable, less sophisticated than they actually were. Each new discovery forces us to revise our estimates upward, to acknowledge that humans, 10,000, 20,000, even 50,000 years ago, were cognitively modern, capable of abstract thought, long-term planning, technological innovation, and artistic expression. This doesn't mean Hancock is right about everything, or even about his central thesis. But it does mean that remaining open to new evidence, questioning established timelines when the evidence warrants it, and acknowledging that we still have much to learn about the past, aren't pseudoscience. They're essential parts of good archaeology. The problem comes when speculation gets presented as fact, when patterns get interpreted as proof without sufficient evidence, when the desire for a compelling story overrides rigorous analysis. What frustrates mainstream archaeologists about Hancock's work isn't that he asks questions. It's that he often presents his interpretations as more certain than the evidence warrants, that he sometimes misrepresents what archaeologists actually think and claim, and that he frames disagreement as conspiracy or dogmatism rather than legitimate scientific skepticism. If Hancock focused more on highlighting genuine anomalies and mysteries while being clearer about what remains unproven speculation, his work would be more valuable and less controversial. Similarly, if mainstream archaeology did a better job of communicating its findings to the public, of explaining what is known versus what remains uncertain, of acknowledging mistakes and revisions rather than presenting false certainty, there would be less space for alternative narratives to flourish. The public isn't stupid. People can handle nuance and uncertainty. What they can't handle is being told something is absolutely true only to later learn it was wrong, or being dismissed when they notice anomalies that don't fit the official story. The greatest value of the debate between Hancock and mainstream archaeology might be that it keeps both sides honest. Hancock forces archaeologists to explain their reasoning, to defend their interpretations, to acknowledge what they don't know. Archaeologists force Hancock to be more rigorous, to provide evidence for his claims, to explain why his theories are better than simpler alternatives. When the debate is conducted in good faith, with both sides listening and responding to each other's arguments, everyone benefits, including the public that's trying to understand humanity's deep history. As we look to the future, several things are clear. First, there's still an enormous amount we don't know about ancient history. Large portions of the archaeological record are missing or inaccessible. Techniques for dating, analyzing, and interpreting artifacts continue to improve, which means some of what we think we know will likely need revision. Second, ancient peoples were remarkably capable. The more we learn, the more impressed we should be with what our ancestors achieved with limited technology but unlimited ingenuity. Third, the past holds lessons for the present. Understanding how civilizations rose, fell, adapted to climate change, and passed on knowledge can inform how we address modern challenges. Whether or not a lost Ice Age civilization existed, whether or not survivors of a catastrophe 12,000 years ago influenced later cultures, the ancient world was rich, complex, and sophisticated in ways that continue to surprise us. The monuments left behind testify to human creativity, determination, and capability across millennia. The knowledge encoded in ancient architecture, preserved in myths, and passed down through generations represents humanity's first attempts to understand the cosmos and our place in it. These achievements deserve respect, careful study, and wonder, regardless of which theory about their origins proves correct. And that brings us to what might be the most important question raised by this entire debate. What are we supposed to do with all this information? Whether you find Hancock's theories compelling or consider them entertaining speculation, whether you trust mainstream archaeology or think it's missing something important, where do you go from here? Because this isn't just an academic debate about events that happened thousands of years ago. It's a question about how we understand ourselves, our capabilities, our place in the long arc of human history, and what we might learn from peoples who built monuments that still stand when so much else has crumbled to dust. The first lesson, perhaps the most important one, is humility. If there's one thing that comes through clearly whether you're listening to Hancock or to his critics, it's that we don't have all the answers. The past is vast and mysterious, and the further back you go, the less certain our knowledge becomes. This isn't a weakness, it's simply reality. History is reconstructed from fragments, from artifacts and structures that survived thousands of years of weather, human activity, and natural disasters. Most of what existed has been lost. Most of what happened left no trace. The stories we tell about the ancient world are necessarily incomplete. This should make us cautious about being too dogmatic in our certainty. Whether you're certain that Hancock is wrong or certain that he's right, that certainty is probably misplaced. The evidence for a lost Ice Age civilization is insufficient to prove the theory. But the anomalies and mysteries in the archaeological record are real enough that dismissing the questions entirely is premature. The truth, as usual, likely lies somewhere between the extreme positions, and honest inquiry requires holding our theories lightly, ready to revise them when new evidence appears. The second lesson is about how civilizations fall and knowledge is lost. This is where Hancock's work, regardless of its factual accuracy, touches on something deeply important. We know from documented history that knowledge can be lost, that civilizations can collapse, that technological capabilities can regress. The ancient Greeks knew the Earth was round and had calculated its circumference with remarkable accuracy. But this knowledge was lost in Europe during the medieval period and had to be rediscovered. The Romans built concrete structures that have lasted 2,000 years, using techniques we only recently figured out how to replicate. The medieval period saw a decline in literacy, technological innovation, and scientific understanding compared to the classical world that preceded it. The Library of Alexandria, which once housed hundreds of thousands of scrolls containing the accumulated knowledge of the ancient Mediterranean world, was destroyed over time through multiple incidents of war, accident, and neglect. With it went irreplaceable texts of philosophy, science, literature, and history. We know these works existed because ancient authors referenced them, but the texts themselves are lost forever. How much knowledge disappeared when that library burned? How many innovations, discoveries, and insights were forgotten? Even more recently, we can see how quickly knowledge can be lost. Traditional skills in metalworking, stone carving, textile production, and countless other crafts have vanished as societies industrialized. Methods for creating colors used in medieval illuminated manuscripts were lost, and took modern chemists years to rediscover through analysis of surviving examples. The recipe for Greek fire, the terrifying incendiary weapon that helped the Byzantine Empire survive for centuries, was lost completely. We know it existed, we know roughly what it could do, but the exact formulation is gone. If it happened once, it could happen again. Our current civilization, for all its sophistication, is remarkably fragile. Much of our knowledge exists in specialized forms, dependent on infrastructure that could fail. Digital storage seems permanent until you realize that file formats become obsolete, storage media degrades, and the hardware needed to read old data becomes unavailable. If you removed the internet, destroyed libraries, disrupted the educational systems that train each new generation of scientists and engineers, how much of current scientific knowledge would survive? How long would it take future archaeologists to figure out what we knew if they were working from the ruins of our cities and whatever artifacts survived. This isn't speculation about some hypothetical lost super-civilization. This is observable reality about how knowledge transmission works. Every generation must be taught by the previous one. If that chain breaks, knowledge vanishes. And throughout history, that chain has broken repeatedly in different places for different reasons. Wars, plagues, climate disasters, societal collapse. Each time knowledge was lost. Sometimes it was rediscovered, sometimes it was gone forever. This perspective makes ancient amnesia, the idea that knowledge was lost and had to be rebuilt, more plausible. Not necessarily Hancock's specific version with a lost Ice Age super-civilization, but the general concept that humanity has experienced setbacks, that progress isn't always linear, that knowledge hard-won can be lost when civilizations fall. The Younger Dryas event, whether caused by a comet or by climate changes, was clearly catastrophic for humans living through it. Populations declined, cultures changed, and it's not unreasonable to think that some knowledge, perhaps knowledge of astronomy or construction techniques or navigation, might have been lost or forgotten, requiring later generations to rediscover or reinvent it. The third lesson is about the value of questioning. The scientific method is built on skepticism, on constantly questioning what we think we know, on demanding evidence and testing theories against reality. But skepticism has to work both ways. Yes, extraordinary claims require extraordinary evidence, but so do claims that our current understanding is complete and certain. When anomalies appear, when evidence doesn't quite fit, when patterns suggest something unexpected, the proper scientific response is curiosity, not dismissal. Ask questions, investigate thoroughly, try to understand rather than immediately explain away. This is where both Hancock and his critics sometimes fall short. Hancock sees patterns and immediately interprets them as evidence for his theory without sufficiently considering alternative explanations. His critics sometimes see the same patterns and immediately dismiss them as coincidence, convergence, or cherry-picking, without fully engaging with what's puzzling about them. Both responses are understandable, but neither is ideal. The better approach is to acknowledge the mystery, investigate it thoroughly using proper methods, and remain open to wherever the evidence leads. The fourth lesson concerns how we think about ancient peoples themselves. There's a tendency, visible in both mainstream archaeology and alternative theories, to either underestimate or overestimate ancient capabilities. Mainstream archaeology has historically underestimated what ancient peoples could achieve, assuming that complex accomplishments must be relatively recent because earlier peoples supposedly lacked the necessary sophistication. But experiments keep demonstrating that ancient peoples with simple tools were capable of remarkable things when they had time, organization, and motivation. Hancock's theory risks the opposite error, assuming ancient peoples couldn't have figured things out themselves and needed outside help, whether from a lost civilization or, in more extreme versions, from extraterrestrials. This inadvertently diminishes the achievements of the actual historical cultures we're studying, suggesting they were recipients of knowledge rather than creators of it. The truth is probably that ancient peoples were neither as primitive as early archaeologists assumed, nor as dependent on outside influence as alternative theories suggest. They were humans, just like us, capable of observation, innovation, problem-solving, and passing knowledge down through generations. The fifth lesson is about the power of narrative. Hancock is successful not primarily because his evidence is compelling to scientists, but because his story is compelling to people. The idea of a lost golden age destroyed by catastrophe, with survivors preserving fragments of wisdom for future generations, resonates deeply. It appears in myths around the world because it speaks to fundamental human concerns about the fragility of civilization, the loss of knowledge, the hope that wisdom can be preserved and transmitted. It's a good story, and good stories have power regardless of their factual accuracy. This is why communication matters. Scientists who dismiss Hancock's theories without engaging with why they're appealing, who don't tell their own compelling stories about the past based on evidence rather than speculation, lose the battle for public attention and imagination. The answer to bad narrative isn't no narrative, it's better narrative. Stories about the past that are both accurate and engaging, that capture the wonder and mystery of archaeology without requiring lost civilizations or ancient astronauts. The sixth and perhaps most personal lesson is about our connection to the past. When you stand before the Great Pyramid or walk among the stones at Göbekli Tepe, or examine precision-carved artifacts in a museum, you're confronting something profound. These objects were made by people who lived thousands of years ago, who experienced joy and sorrow, who looked up at the same stars we see, who wondered about their place in the cosmos and tried to leave something permanent for the future. They succeeded. Their monuments outlasted their civilizations. Their names were forgotten, but their works endure. This creates a kind of kinship across time. We're connected to them through our shared humanity, through the fact that we face similar questions about meaning and mortality and legacy. What Hancock's work does, whatever its flaws, is make people think about these connections, make them aware of how deep human history runs, make them wonder what we might learn from peoples who came before us. That impulse, that curiosity about our deep past and our place in the long story of humanity, is valuable even when specific theories about lost civilizations don't hold up to scrutiny. So, what should you do with all this? If you're intrigued by these questions, the answer is to learn more. Read Hancock's books if you haven't, but also read the responses from archaeologists. Look at the evidence yourself. Visit ancient sites if you can. Study the methods archaeologists use to date artifacts and interpret data. Understand that archaeology is a science, with rigorous methods and standards, but also that it's an incomplete science, working with fragmentary evidence. Both Hancock's theories and mainstream archaeology's interpretations are attempts to make sense of limited data, and both should be evaluated critically. Don't accept everything Hancock says at face value. He's presenting a case for a specific theory, and like any advocate, he emphasizes evidence that supports his view while downplaying contradictions. But don't automatically dismiss everything either. Some of the anomalies he highlights are real. Some of the questions he raises are worth investigating. The debate has pushed archaeologists to explain their methods and interpretations more clearly, which benefits everyone. Similarly, don't assume mainstream archaeology has everything figured out. The history of science is full of examples where consensus was wrong, where new evidence overturned established theories, where outsiders asking different questions led to breakthroughs. But also recognize that there are good reasons scientific consensus exists, that theories become accepted because they're supported by evidence and survive attempts to falsify them. Changing consensus requires presenting better evidence and better explanations, not just pointing to mysteries and speculating. Be skeptical of certainty from any source. Whether someone is absolutely certain that lost civilizations existed or absolutely certain they didn't, that certainty probably reflects ideology as much as evidence. The honest answer to most questions about the ancient world is, we don't know for sure, but here's what the evidence suggests. Anyone who claims complete certainty about events 10,000 years ago should be viewed with suspicion, because the data simply doesn't support that level of confidence. Support good archaeology. If you're fascinated by the ancient world, support museums, educational programs, and archaeological research. Donate to projects if you can. Visit sites responsibly. Share interesting findings with others. Help create demand for serious archaeology communicated in accessible ways, which creates incentives for more scholars to engage with public audiences. The more people understand what archaeologists actually do and how they know what they know, the harder it becomes for misleading theories to gain traction. Stay curious. The ancient world still holds countless mysteries waiting to be discovered. New sites are found regularly. New analytical techniques reveal information we couldn't access before. Underwater archaeology is still in its infancy, with vast areas unexplored. Genetic analysis keeps revealing unexpected connections between ancient populations. Each year brings discoveries that refine or revise our understanding of the past. This is an exciting time to be interested in ancient history because we're learning so much so quickly. The technology available to modern archaeologists would seem like science fiction to researchers working just a generation ago. Satellite imagery reveals hidden structures beneath jungle canopy and desert sand. LiDAR mapping creates detailed three-dimensional models of ancient sites without disturbing the ground. Ground-penetrating radar lets us see what lies buried without excavation. DNA analysis extracts genetic information from bones thousands of years old, revealing population movements and relationships. Isotope analysis tells us what ancient peoples ate, where they grew up, even what season they died. Each technological advance opens new windows into the past, and the pace of discovery is accelerating. More archaeologists are working in more places than ever before. Sites that were inaccessible due to political instability or lack of funding are being studied. Underwater archaeology, once limited to shallow coastal waters, now explores the deep ocean floor where ancient coastlines and settlements lie preserved. Climate change, ironically, is revealing sites previously hidden under ice or permafrost, though it's also destroying others through erosion and thawing. This means that definitive answers to many questions about the ancient past may come sooner than we expect. Better dating methods might resolve controversies about when sites were built. More complete excavations might reveal the developmental sequences that show how techniques evolved. Discovery of new sites might fill gaps in our understanding of how cultures spread and interacted. The mysteries that seem insoluble today might be resolved tomorrow through new evidence or new ways of analyzing old evidence. But remember that mystery and uncertainty aren't problems to be solved with speculation. They're invitations to careful investigation. When we encounter something we can't explain, the proper response is, "I don't know, let's find out." Not "therefore lost civilizations" or "therefore mainstream archaeology is wrong." The ancient world is fascinating enough without requiring elaborate theories. The actual achievements of ancient peoples, working with the tools and knowledge they had, are impressive enough to command our respect and wonder. In the end, whether Graham Hancock is right or wrong about the specific details of his theory may matter less than the questions he's pushed us to ask and the conversations he started. We should know more about our ancient past. We should question assumptions. We should remain open to new evidence while maintaining rigorous standards for what counts as evidence. We should tell better stories about the past that capture the public imagination while remaining grounded in facts. And we should approach these questions with a combination of skepticism and wonder, recognizing that the past holds both answers and mysteries, and that the process of discovery is valuable in itself. The debate about lost civilizations and ancient technologies will continue, probably for decades. New evidence will emerge, theories will be refined or abandoned, and future generations will look back at what we believed and shake their heads at what we got wrong. That's how knowledge progresses. But in the meantime, we can engage with these questions thoughtfully, learning from both the evidence and the debates, building a better understanding of who we are by understanding where we came from and what humans have been capable of throughout our long history on this planet. The controversy surrounding Graham Hancock's work reflects larger tensions in how we understand and communicate about the past. We live in an era of declining trust in institutions where expertise is questioned and alternative narratives find ready audiences. This isn't entirely negative. Healthy skepticism toward authority has driven progress throughout history, but it can also lead to rejecting genuine expertise in favor of more appealing stories that lack evidential support. The challenge is distinguishing between legitimate questioning of assumptions and rejection of evidence-based reasoning. When archaeologists revise their understanding based on new discoveries, that's not evidence of previous deception, it's evidence that science works. When they maintain consensus on certain questions despite challenges, it's not necessarily dogma. It might be because the evidence really does support the consensus view, and alternative explanations don't hold up to scrutiny. At the same time, the scientific community must acknowledge its own biases and limitations. Academic disciplines can become insular, protecting established theories even when anomalies appear. Young researchers proposing unconventional ideas do face career risks. Funding does tend towards safe, incremental projects rather than risky challenges to paradigms. These structural issues are real, and they can slow the pace of discovery and revision. The Hancock debate, then, serves as a kind of stress test for how we handle controversial ideas about the past. At its best, it encourages mainstream archaeology to communicate better, to acknowledge uncertainties more openly, to engage with public curiosity rather than dismissing it. At its worst, it promotes pseudoscience, undermines trust in expertise, and attributes indigenous achievements to mysterious benefactors rather than human innovation. Finding the right balance requires good faith on all sides. It requires Hancock and similar researchers to acknowledge when their theories lack sufficient evidence, to engage seriously with critiques rather than dismissing them as orthodoxy, to distinguish speculation from fact in their presentations. It requires mainstream archaeologists to take anomalies seriously, to communicate their methods and findings accessibly, to acknowledge the limits of current knowledge without abandoning scientific standards. Most importantly, it requires the public to develop better critical thinking skills, to understand how evidence works, to recognize the difference between interesting questions and proven answers, to appreciate that mystery and uncertainty are part of the process of discovery rather than evidence of conspiracy or cover-up. As we close, whether you're convinced by Hancock's theories or remain skeptical, whether you see him as a visionary or a provocateur, one thing is certain: the ancient world still has stories to tell. Those stories are written in stone, encoded in monuments, preserved in myths, and scattered across continents. Deciphering them requires patience, rigor, and an open mind. It requires both skepticism of easy answers and willingness to question established certainties. Most importantly, it requires recognizing that the people who built these monuments, whether or not they were influenced by some earlier civilization, were humans like us, capable of extraordinary things, leaving messages we're still learning to read. And now, before you drift off to sleep with visions of ancient mysteries dancing through your mind, I have one small favor to ask. If you found this journey through Graham Hancock's theories interesting, if you appreciate the work that goes into researching, writing, and presenting these stories, please consider subscribing to the channel and leaving a like. It helps more than you might think, ensuring that we can continue exploring the fascinating corners of history, from ancient civilizations to modern mysteries. Your support makes these deep dives possible. Until next time, sleep well, dream of ancient stones standing under eternal stars, and remember that the past, like the future, holds more possibilities than we've yet imagined. Good night.